Alright, so now we're going to look at the different ways we can graph a linear function. And the first we're going to look at is the table of values. Now, it's really not one that I would recommend because it gets long and annoying and takes a lot of time, and there really are simpler ways of doing it. But we're still going to take a look at it. What we're doing using a table of values is we're finding values of x, and then we're making it going through this equation, this sort of transformation we talked about earlier, and we get a y out, and then we place them on the graph. So one thing you want to make sure of when you're using a table of values is you want it to find x's that it'll go through at least two quadrants. And what quadrant is this thing. That's a quadrant. It's one of those squares. And a graph has four. That one, so this one, this one, this one, and that one. And you want to make sure you go through at least two. So we don't see where a part of a line is going, but really where the line is directed and really where it's going to go. So let's start. Is this? Alright. So we're going to start with x is equal to 0. Well, when x is equal to 0, y is equal to negative 3. And how I found that is I really just substituted in 0 for x and then I solved the equation. So when say x is equal to negative 1. So negative 1 times a half, that's negative a half, minus 3, that's negative 3 and a half. Say when it's equal to negative 2. So that would be negative 2 times a half, that's negative 1, minus 3, it's negative 4. And then we say maybe negative 3. Negative 3 times a half, that's negative 3 over 2, minus 3, that's negative 4.5. So negative 3 would be negative 4.5. Let's try positive numbers now. So let's say x is equal to 1. So 1 times a half, that's a half, minus 3, that's negative, so this is a 1, and this is negative 2.5. Write that better. It's a 1, and that's negative 2.5. Let's try when x is equal to 2. Well, 2 times a half, that's 1, minus 3. That would be negative 2. And it's equal to 3. So 3 over 2 times 1 half, so that's 3 over 2, minus 3, that's negative 1.5. Alright, 4, when x is equal to 4, so that would be 2 minus 3, negative 1. Now let's plot all these points, and I'm going to plot them in red. So x is equal to negative 3, 1, 2, 3. Y is equal to negative 4.5. 1, 2, 3, 4, 5 and a half. Oh, 1, 2, 3, 4 and a half. Okay. When x is equal to negative 2, we have negative 4, so that would be here. Negative 1, that's 3.5. 0, we have a negative 3. 1, negative 2.5. So when x equals 1, we're at negative 2.5. When we're at 2, we just every time go up a half. There. And when it's 1, 4, we are at negative 1. So if I draw the line out. So as you can see, using a table of values is not the most efficient way of doing it. But I actually do use it sometimes. For example, in quadratic equations, when it's harder to find, to draw the line in the simpler ways. And you do use it. You don't have to use 9 points to find your line, especially in linear when it's going to be a straight line anyways. But it's always a nice thing to know in case you forget other ways or you don't feel you can use other ways.